Firstly, we will be editing the frame a little bit more, as you can see here. The backside needs a little bit more work before we can start working on the suspension. And the first thing I need to change is those holes at the back are a little bit too small. I select both of them with row selection and then scale them slightly smaller. The shape also needs to change a little bit. So for that, we will just move these verts in slightly. Minor adjustment should be good enough. And once smoothed, this looks okay. We also need to fix these verts, which are misaligned. And then I want to move in the back of the frame a little bit more to make it slightly shorter. The back of the hydraulic clutch needs to be moved in also. And this small dent should be fixed too. Now we'll be building this side part of the bulldozer, which I'll be referring to as the suspension. It's a pretty complex object with a lot of mixed shapes. And I'm starting off by drawing two cylinders here, drawing these in side profile and then rotating them because then I can get their radius exactly right. Once they're rotated, I move them outwards into the approximate correct position. And then I reduce the number of sides and the number of segments so that I can work with these easily. It's important that I don't pick too few. I also want to get them in the correct position opposed to each other. Then I create a box, which will be the second part I need for this first part of the suspension, which is actually a box at the bottom and it transforms into a half cylinder at the top. So we'll need to do some tricky modeling to get that fixed. It's an interesting part, should prove a challenge to make. Selecting these edges, and now I'm activating my graphite tool in Max because they seem to have turned off again. I'll be using the Swift loop to add an extra edge there. This extra edge will help me to extrude these polygons. There's a sort of thicker border around that, and for that I need to select those polygons and extrude them. I want to scale this down slightly so the difference is more obvious, and then I will delete one of the open sides. I'm aligning those two sides on the x-axis, and then using Swift loop again to add extra edges. Some more extra edges. The bottom part I can delete. I'm going to leave that round part there at the front because I will need it to create a round hole. I'm connecting these two sides. And I'm moving this outward slightly so I can get the angle right. This needs to be slightly smaller, I think. Move it downwards a little bit. As you can see, it's easy to start with basic shapes here and then just create the connections between them yourself. So I'm using snapping here to align my sides. And I'm extruding this part. And then using snapping again to align those two edges. I'm just going to weld the two vertices so that they are connected. Move this down slightly. I want the slope between those two parts to look correct. Shouldn't be too bumpy. Now I'm adding an extra edge in the center because I'm most likely going to use symmetry on this part. Swift loop to add some extra edges, and these are just so that I can bridge the opposing edges here. Now I need to snap this to the center so that it's nicely aligned. And as you can see, these are also not planar anymore, so I'll use the Make Planar buttons to fix that. I need to move those so that they are also aligned. Again, using the Make Planar buttons. And now I need to look into using this big part at the rear. I'm also going to delete half because I will use symmetry on this part. You don't really see the inside. It might be slightly different. I don't have any reference on it, so I'll just presume that it's the same as the other side and use the same model there. Now I'm creating the backside of this suspension part, snapping it to my symmetry center, then using connect add another edge, and then ridging these edges to close up my open geometry. I'm paying attention so that I always have opposing edges. There's never a mismatch between the number of edges. It might happen when sometimes it's unavoidable, but then I will always try to fix that because I want to avoid having any tries in here. As you can see, that looks like a try, but it's actually not because I have an edge arriving there at the bottom, which turns it into a quad effectively. Using Swift Loop to add some control edges. I want all these lines to be hard, so I'm adding control edges there. And using Swift Loop again to fix up the bottom. And what I'm doing right now is I'm adding some extra loops here, because in the very center of this part, which I'm pretty sure there's a hydraulic piston in here. This hydraulic piston adjusts the tension in the tracks of the bulldozer. And there's some sort of round hatch at the side, and this round hatch is pretty tricky to model because it's actually two cylinders that cut and extrude into each other. So right now I'm adding some edges to prepare the work for cutting a cylinder in there. As you can see, I have quite a few edges. It needs to be a little bit wider. And once I have that, I will select these two and move that up. Scale it in. There we go. We have a round shape at the bottom. And I'm going to have to do the same thing at the top. But first I want to fix the position of these planes. Those polygons, it's not correct. They need to extrude inwards. So I'm moving this inwards using the Make Planar button. And once I have that, I'm going to bridge the opposing edges. Also bridge those. And now I can do the same here. Bridge these opposing edges. And we'll use Target Weld to simplify the geometry a little bit there. Add another edge. Connect those. And it turns out I just wanted the position of those lower, so that's why I did some geometry changes. I'm doing the same thing here, and very important here is that I'm using face and edge constraints so that I cannot move my vertices outside of the existing faces and edges. I turn this on with Shift X. And I toggle a lot between it. You might not notice me doing it, but with this tricky stuff, it's important. Now the top half extrudes outwards and the bottom half extrudes inwards, so that's what I'm modeling right now. Weld those bottom vertices. I'm going to add a connect there to turn those tris into quads. It turns out that these polygons, I won't really need them. I'm best off selecting these and then extruding again, using the Make Planar button, very handy with this sort of work. Snapping back into position, and then welding those open vertices. I will select these and snap them to the same position so everything's aligned and they end up on the same position on the y-axis. Just doing some extrude with snaps so that I can close this up. It's easier to use extrude in a few steps instead of bridge because then I don't have to do extra connects afterwards. As you can see, we have a slight problem. It's not exactly round. I'm just trying to see how I will do the sharpened edge around there. It seems like a connect with a scale works fine. Same here at the front. That fixes my tri, turns it into a quad. But the problem is here, we don't have anything round, so I'm just removing that control edge again. Scaling this out. It needs to be a lot rounder. Selecting those, extra scaling. And I think at the top there, we have too many edges. The ones I'm target welding right now, they're just too much. We can't use those. So I'm getting rid of them by target welding everything together. And you might be thinking, yes, but there are tris now at the outsides. We'll fix those later. First we have to get our important shape, which is the circle that is extruded from the side. We have to get that fixed first. So what I'm doing is I've created a cylinder, and I will use this cylinder to snap everything into the correct position. Turn the cylinder in X-ray mode with Alt X, go into vertex mode, do some selections, and once I have these selections, I'm moving them down and into the correct positions. Selecting my center line for the circle, and then using snapping to align it with the correct cylinder. Note how edge snapping is on the right, and I'm using this edge snapping to snap all these verts into the correct position. Well, sometimes I turn it off because it depends on what sort of geometry you're working with. Looks like almost everything is snapped down, save for a few exceptions here and there. And that looks like everything is aligned. Then we can delete this one. And I will now select all the front faces of that cylinder and perform an inset so that I have control over the sharpness of the edges there. Another connect here. Turn my tris into quads. And now I can actually start to do... Well, first I need to fix this a little bit because you have to make sure that all your verts stay planar. When working with a tricky shape like this, it's easy to lose sight of how everything is aligned. Right now I want to check Turbo Smooth, so I unhide my frame, copy the Turbo Smooth, and paste it as instance on the model I'm working with. I can hide my frame again so it doesn't interfere with my work. I'm performing some extra cuts, and the reason for these is to fix the tris I have on the side there. Some target welding. Bridge these, then remove that one with backspace, and bridge these again. The shape's looking a little lumpy there. I might have to do a few adjustments. Move that one inwards, slightly upwards. And after that, I'll perform another inset here. That looks correct. Create another cylinder. And with this cylinder, I will start to create the sort of lid that is on that cylinder. And it's an interesting lid because it has these alternating holes on the outside. And in one of every two holes, there is a space for a nut. And I'll just perform an inset, then select alternating polygons, inset, and then use a bevel with the geometry I created to go for the same sort of geometry here. Move that inwards. Use Swift Loop to add control geometry. I also need to make it stick out less. Rotate it slightly. And then I've attached it. Looks like I need to make a few more adjustments. Sometimes Swift Loop is a little bit hard to use. If that happens, I decide to switch to Connect. Swift Loop is faster if it's cooperating. If it's not, just switch to Connect. Once I've added a control edge there, I'm adding an extra one here. And I'm moving this one outwards because I know there will be some extrusions at the bottom. And these extrusions serve to connect with these small wheels at the bottom of the suspension. I'm selecting the geometry for these small parts. Once I have this geometry, I need to make a few small adjustments so their scale is right. Then I do an extrude and scale them down. Another Swift Loop. Then I select those 4 polygons. And I'm going to perform an inset on this so that the bottom parts that I just extruded will be rounded off instead of square. I can remove this extra edge. It's interesting to use an inset sometimes because an inset makes sure that you have a rounded shapes instead of hard shapes. Well, the square shapes. Selecting these polygons again, forming another inset, and the purpose of this inset will be to create a round shape. I'm going to create another cylinder with 8 sides, and I will use the cylinder to align all the vertices of my newly inset geometry so that I can get a nice cylindrical shape. Turn on snapping again with Shift S, and then snap all the points. Move my cylinder and do the same thing with the snapping. There we go, all done. Can't see the cylindrical shape yet. To visualize it, I'm going to scale them up slightly and then perform an inset. And after that inset, I will perform a small extrude inwards and another inset to make sure the edges stay hard there, with a final inset and a small extrude inwards to create this tiny hole. Once that's done, I'm going to focus on this front part. And this one's a bit tricky because there's a big piston coming out of the suspension here, and it sits in this big hole. And when working with this symmetrical mesh, as you've noticed with the frame we were creating, it's always a bit tricky to get the symmetry working. I'm just going to leave that hole at what it is and work on the back part. The back part, it's a semi-round shape, and out of that round shape we get the square part for the back that holds the rear lower roller of the tracks. Now I'm aligning this mesh so that I can start connecting them together. I need to move these outward slightly to give me some space to work with. And then I'm going to start deleting the faces that I won't need. When that's done, I start welding parts together. And I need to make sure that I stick to the verts of the cylinder because I want to keep the round shape for a few insets and the like. That one's going to give me a little bit of trouble, so I decided to have a sort of a loop running around the top. And this is really a tricky part because we have square shapes connecting in all sorts of crooked manners, so I'm going to have to be a little bit creative here. Moving that down, forming an inset here, and I'm doing this inset so that I can safeguard the cylindrical shape on the inside there, that I don't accidentally move one of the verts. Now I'm performing an extrude with a few faces so that I can create the back of this part. Performing a small extrude there, and that way I can connect all of these edges together. And as you can see, there's a slight problem that one side has 3 segments and the other has none yet. I'm going to have to add those. Back to the top, make sure that I can connect everything together and that I keep the correct shape. I'm moving the edges around there. And then I go back to the back part and add another swift loop that allows me to weld some vertices. After that, I'm moving a few edges around, and I'm just building more framework so that I can connect all these parts together and weld these vertices and close up the shape. Right now I have a try there. We'll get back to that one later. Forming another inset here, and now I'm creating the base of this big shape here. And what this is, this big round shape, is there's a big axle running through the entire bulldozer, and what connects to this big axle is the arms or the blade at the front. So this is a pretty important part. It has to be a very solid and sturdy axle. I'm not sure what the connection for the arms for the blade will look like, so I'm just creating a basic temporary shape, which I will return to later. This is just simple extruding work, nothing too complicated, but it looks pretty good already. I'm going to go back working on the back here. A bit of a problem here is that I have multiple edges to work with, which makes it a little bit more difficult to get that slanted shape in there. But working carefully will eliminate most problems here. Moving these verts so that I don't have too many crooked lines. And that's starting to look okay. Use Swift Loop to add another hard edge there. And we have a slight problem here. You can actually remove that one entirely. I'm adding an extra loop here, and the purpose of this loop is not to go around the cylinder, that's why I only selected half, but it should go from the back of this part around the cylinder and looping back to the back again. You can see I'm preparing for this loop, and right now I'm just going to connect them up. Like these, connect, target weld them, move that point slightly, then select these two verts and do the same trick there. Then using Swift Loop. And my edges are a little bit compressed here, so I would prefer to move them a little bit. I will use Cut to fix up this bottom, because I'm always going to try and avoid non-quads as much as possible. Simple fixing up this backside here, just using bridge, a little bit of target weld. Then using Swift Loop to add another control edge. It's getting pretty busy over there, but it doesn't matter so much since it's a difficult area and we're keeping things under control. Trying to work with basic shapes first and then going into details, and that avoids the problems of having bumpy and wavy geometry. Adding some extra edges here so that I can create more details in the center of this rear arm. And the main point is that I have a square shape here. The square shape will allow me to create a hole in this side. This hole has to be round, so I need to start off from a square. Then I just select these points, scale them together, and it pretty much looks like a cylinder. If I would want to be completely safe, I would use the same snapping technique, but I'm not going to do that. I'm just going to eyeball it because I'm pretty sure it will work. Same deal, a few extrudes, a few bevels, and I'm creating this small hole in the center. And just eyeballing the roundness here. And there you go, in Turbo Smooth, it looks almost perfectly round. Shape is starting to come together nicely, but we still have a lot of work to do on this. It's one of the most complex parts of the bulldozer, but also one of the most fun ones to work on, because I think personally there's a few interesting challenges here. We haven't tackled them all yet. This edge serves to eliminate some problems there. And right now we have to create an opening in the back. Why is this opening there? Well, as I mentioned before, there's going to be a roller clamped between these two arms at the back. Now, this roller just guides the track. It's one of the main wheels of the bulldozer. Now I'm just aligning these verts so that they are prepared for bridging. Bridge is a really interesting tool. I like to use it a lot. It's way faster than Create Polygon. It's also faster than just manually extruding and welding together. Everything bridged. Then I need to fix some problems here. I have a lot of rogue loops here, loops that just I need to get rid of before they start messing up the rest of my geometry. And the best trick for that is to have them loop around and loop into itself, like I did with the cylinder at the side, like I did with the top of this part right here. I'm just gonna eliminate all these loops as much as possible. Right now I can use this loop to harden the edge over here a lot more. There we go, all quads, and it's going to work fine in Turbo Smooth. What we have right here is some polygons, which I will use to add a little bit of extruded detail onto my model. On the reference, I could see a small extruded area here, some sort of squared, rounded beveled box that comes out of the side of the suspension. Now, there's a little problem at the left side over there. I'm going to fix that. Because of the beveling, some vertices have shifted into each other. We just need to move them about a little bit. I've removed one loop because it will be easier to work with. Shifting them around a little bit to get a nice flow in there. I need to move these up slightly so that the edges are aligned. And that actually looks good. So onto the next detail. I'm going to have to remake this part here because there's another slight extrude here. Need to add some more polygons for that. Delete the ones on the inside because I don't need those. And these also need to go. Cutting an extra edge here so that I can run this loop around. I can delete those, and now I can just use target weld those together. There's still a slight problem with a try at the corner there. We'll get back to that. Just adding some more control edges first. Another cut. And then we'll remove this one and we have our quad back. Once that's done, I'm going to do some slight adjustments here. Now we have a nice loop all the way around. And I can do the control edge around this side. Once that's done, I'm going to remove those. And cut these back in. So I see I changed the topology a little bit just to be able to perform that operation. It's a trick to work faster. You don't have to do that. You can select manually, but I prefer to do it this way in such a scenario. I've just detached the inside here, that cylinder, and deleted the other half. And right now I'm going to add a symmetry on top. And that symmetry will help me check if all these center edges are aligned nicely. And there might be a slight problem. There we go. As you can see, the suspension is sitting too close against the frame, so I'm adjusting it slightly. It also matches the position of the tracks on the blueprints way better. There's a little opening here. Just going to select these edges and then use snapping to move them into the correct position, like that. Now I'm aligning the pivot to that cylinder. And once that's done, selecting all of these. And then I will set my pivot to the parent position and move this around slightly. I need to make it a lot bigger. When comparing to references, it might be a little bit small. So I'm just upscaling all of this. A few verts move out too much. So I'm changing the position on them. I'm trying to make sure that I don't do anything too extreme here. And there we go, that's all fixed now. Now I'm creating the big piston that comes out of this part of the suspension. As I said, this piston will push a block in front of it forwards, and that way the tracks will get stretched and they can actually be compressed or stretched, which allows for control over the track tension. Deleting that bottom side so that I have something to work with for the next part of the suspension. Moving these out, snapping them to the exact same positions as the other part. Doing the same thing over here. The top doesn't have to be the same, that's slightly different. Once that's done, I will bridge these parts. There we go, bridged. And then I will perform an extrude on these. Weld that point. And then add a connect so that I have some control edges up there. And I'm deleting these two, extruding these outwards. And this one I'm snapping so that they sit on the symmetry axis. Snapping those together, welding them. And I'll select these edges and extrude them downwards to create the rest of my topology. And you can see with these complex shapes, I use snapping a lot. It's really handy to work with this tool. Again, Shift S to toggle it on and off if you didn't know that already. Adding some more geometry here at the back. This is a pretty tricky part also. The slanted side goes into a straight side and we need to make sure that works. Target welding these points together and using snapping to extrude them to the correct height. Use Swift Loop again to add control edges. Moving those to get that slight rounding in there. Then selecting this loop, the entire loop, and then doing a shift move. And apparently I forgot some, quickly fixed with a bridge. Once that's done, here's another control loop. And I'm going to add another extra loop on top here. Reason for that being fixing the try all the way at the bottom. Prefer to get those all the way to the left side because it would destroy the corner, the rounded corner I have at the top right there. The left hand, it's way better. So there we go. That looks okay. Now I'm moving these slightly. I'm trying to see where my blueprints are going. It's a little bit hard to see because it's covered a lot by the attachments for the blade. Using snapping to move them around slightly. Then perform a slight extrude like this. Also going by the pictures a little bit when estimating the proportions here. Then perform a chamfer so that I have a hard edge there. Once I have these selected, I perform a few shift extrudes using snap. A quick weld to make sure I don't have any open vertices. And then I'm adding some extra loops with Swift Loop. And I'm changing the topology slightly here, which will allow me a little bit more control. Like that. It's starting to look like something. I'm going to have to delete the inside here. Well, bridge the inside also, because it's the same deal as at the back. There's a roller, a wheel in there, and there has to be some open space for that wheel to fit in between. More edges here. There we go. That's another try fixed. This is still a little bit too wobbly and round, so I'm adding some more control edges to fix the hardness of those edges. And I'll use Swift Loop again at the bottom here. In this Swift Loop, I need to tweak slightly to get that rounding in there. And I'm capping this side, and this is a tricky part. The front of this suspension part is actually inset and extruded, so there's some sort of slot in there, and I need to make sure that slot looks correct. Adding some control edges, simply adding one, but this is looking way too rounded and not very controlled. Need to add another loop over there, which is starting to look better, but we still have an artifact at the right there, which we'll get back to. Forming a slide inset here, and the reason for this inset is same deal as we've done before. There's a cylinder there for the axle that holds the roller on the inside of this part. Created the cylinder, and now we just got to start aligning the points one by one. And you can see it's slightly rotated, but that's not so hard to fix. Just like this, rotate it, which looks like a little bit more of a natural position. Form an inset, and then the same deal, an extrude. Two extrudes, another inset, and a big inset, and then we're going to create that small hole in the center again, which is just a few more extrudes and insets. And we're performing an extrude here. Moving this up slightly. Because there's a little ridge here, I'm using this extrude. It's a little bit troublesome to get that in afterwards, but we'll make it work. I'm moving these edges upwards. Why? Because I want to have this loop running around the outside part of this sort of this upstanding part, which shields the piston from the front part. Welding those together, selecting the loop, adding another one. There's a little hole in there, which is the reason I added this loop. Just bridging that, and if you want a round hole, well, then I'm going to need a perfect square here. So I'm just manually moving these points around until I get a square shape. An inset, scale that up slightly. This is starting to look okay. I'm just using Connect to add two more loops in there. That looks okay. I forgot a little part in the center there. Nothing difficult, just selecting it and then using Snap to get this into the correct position. Make some slight adjustments to the sharpness of the edge there, and the position needs to be a little bit larger. I have to watch out that I have two sides to adjust. Once that's done, I'm going to use the nut I created before, and I'm going to use it all over the part we just created. And there we have all of them. It's a pretty interesting shape, and I always try to randomly rotate my nuts so it just doesn't look too artificial. Reusing them, moving them up slightly, and scaling them like that. Move them into position now. something like that. And then just a little rotation to double the amount. It's looking a lot better already. Okay, now at the top of these parts, there is a little box. This box shape has some nuts on the side also, which we'll add right away. Right now I just gotta add some more edges in here to control this surface. Inset. And then use Swift Loop. Using the same nut model. Completely aligning it to that little box. And then doing a local movement of the nuts, because it's way easier to position them like that. When working with lots of complex mechanical separate objects, it's a good idea to have full control over your coordinate systems and your pivot alignments. It makes working a lot easier. Now we've attached everything. Move this down slightly. And that looks fixed. The bottom of this part here is actually open, and the previous model wasn't correct yet, so I've just deleted those edges, and now I'm fixing up the bottom here. As you can see, it's a little bit of a sloppy part of the model down there, so we're going to fix that up a little bit. Bridge these. Once that's done, I'm going to have to add some more loops. At the back here, we also have some loops to fix. There's the same deal here. There's an inset and an extrude. We've added that. It's a little bit too rounded. It's going to need another loop. And this loop we're going to solve with a little trick. Just locally perform an inset. But it turns out that the inset is messing up the geometry a little bit. And nothing is really working. So in such a case, what I'm going to do is use a scale on that. And then just manually adjust the positions of some of the vertices. At the top here, I'm also going to do the same inset trick, but since it's not a slanted angle, it doesn't pose any problems. Once I have these, another inset, and we're all done. So as you can see here, inset is a great way to locally add some sharp edges without the risk of having them run around your entire model. I'm going to do some fixing at the front here. Adding some edges with the connect tool. And there we go. That one's fixed. Extrude that slightly. And I want to match the other side in terms of geometry here. I don't want to have one segment on the right and two on the left. I want it to be equal. I'm actually modeling this using some bridge and shift move. I'll need a bit of tweaking. Just move the verts around slightly. Once that's done, I'm going to create the next part of the suspension. And as you can see at the bottom, there's a ton of tiny rollers. And it's a good thing that these tiny rollers are pretty much 4 times the same model. So I can just model one, then copy it around with some slight adjustments. So I'm starting this part with some simple box modeling. Just moving the verts around into the positions that I think are correct compared to the blueprint. Turn on X-ray mode, and I've done that because these suspension parts at the bottom are made up out of multiple parts. Just using this little box, scaling it up, getting it into the correct position. Just simply blocking out the basic parts for this mesh. This part is really pretty simple. So just adding control edges to a box and then performing an inset. And the reason I perform that inset is because I want there to be a round shape in the center. It's getting up slightly. I'm just eyeballing the roundness again, not using any snapping. Then I'm doing a chamfer, because what this part is, it's actually two halves that clamp together on an axle that holds the small rollers. So now I'm opening this one, and I'm going to select all these parts and delete them. Once I've done that, I will select these, the opposing polygons, and bridge them, and I'll just delete these two planes which I don't need. Next up, I'll bridge the open ends one by one, the front, the back, and just select them and hit bridge all the time. I'm just bridging the opposing ones to close up any gaps. I'm not using cap here because you can only use cap on single polygons. You'll have to do cutting afterwards. So this is what the basic part looks like. It's still way too round, so I'm going to have to add some more geometry for that. That's a little bit better. But as you can see, there's a slight problem with the cylinder because I cut it open in the center. It's not, even though the blow pulley shape is round, the smoothed shape isn't exactly round anymore. Fix that. I'm moving the verts around a little bit. I want my edges here to be slightly rounded, so I'm selecting them, moving them inwards. I actually want the top part to be more rounded than the bottom, so I'm just leaving the bottom part, or the base part, as it is. Once that is done, I'm going to add the axle on the inside, forming an inset. Then another inset for control edges. Another inset, and I'm just creating this hard edge in the center. After that's done, I'm just going to attach the mesh I just created. As you can see, it's scaling down. So I'm increasing the size. That looks about okay. I want to do some slight adjustments to these polygons here. So in side view, I'm selecting them and scaling them slightly. This is pretty tricky to work with, but now that I have a reference cylinder, I can just eyeball it. Once that's done, I'm moving these parts upwards so that you can't see the base of it. And what I need now is two of those nuts. And I'm going to put those nuts on the head of this part. Aligning it, I'm going to move it down. A 90-degree rotation with angle snap, and just move them in the correct positions. Still a little bit too small, so I'm scaling them up. And once that's done, I'm creating a copy down there. Again, the random rotation, then I attach them. And now that they're attached, I'm going to start creating an extra part here. At the front of this suspension part, there's this sort of oval-shaped bulge. And since it's an oval shape with a cylindrical shape in the center, so I'm just going to start off with the cylindrical shape. Easier to create an oval from a cylinder than the other way around. Once that's done, I scale those parts outwards so that I get my oval, and I've still kept this inset for the cylinder in the center. Now that that is done, adding these extra loops to control things. I'm then performing an inset. And once that's done, I'm just going to use scale again to move these outwards so that I can get the rounding right. Again, tweak work to get things seemingly right. That done, I manually select these polygons. With these polygons selected, I'm going to create the bulge. The bulge is actually a round shape with these sort of indents for another nut to sit in. That done, moving those down. Move this one up, and can't forget these parts. It's looking better. And I'll perform a bevel on this one, and a final bevel over there. I'm leaving an unquad in the center there, but it doesn't hurt since it's just a cylindrical shape. It won't do anything too bad. That done, I'm going to space these edges out a little bit more so that the rounding of that shape turns out a little bit better. There you go, that looks okay. These inwards, just to tweak it a little bit more. That should be perfect. I want to get the bulge a little bit more obvious, so I'm scaling it in the Z direction. There you go. That little part is becoming slightly visible, so I need to move it outwards. Now that I have these, I'm going to do another inset. The inset has made the edges a little bit harder and more controlled, which is better. Again, I can use the nut, so I'm copying it. And once it's copied, I'm moving it into position, scaling it down slightly, and just aligning it correctly. Random rotations added. With the bolt done, I just attach it. I'm attaching a few parts, as you can see here. That's just to keep the object count down, since Max is slowed down more by multiple objects than it is by a high poly count. I'm going to continue working on the base part now that I have made some extra small details. I prefer not to model these in separate parts, since on the real bulldozer they will be separate parts, and I would just be needlessly complicating things by attaching them together. There's an extra part beneath this base, and this is an interesting part. I'm not exactly sure what it does, but my guess is that it keeps the tracks for the bulldozer aligned. It makes sure they don't run off the wheels as they press against the sides. It's this sort of L shape with a few indents and bolts attached to it. So I'm simply box modeling an L shape, forming an inset to get a rounding on one side, adding control edges, I'm adding extra control edges here. Why am I doing that? Well, I'm adding these extra control edges because there's an indent, and this indent needs to have control edges. I can place those in afterwards, but I prefer to do it before I actually extrude it. There we go. That looks good. Need to attach that part and see what it looks like with Turbo Smooth. And that is okay, but I think it could use another control edge over there. I can move these outwards, and maybe I need to see what it looks like with a nut. Scale that one up. And inside that indent, that extruded square, there's also space for some nuts. And these are actually bigger. Of course, I need to rotate these. Well, these I prefer not to rotate at a random angle because you could see on the reference pictures that they actually sit nice and straight. Apparently the guys building this bulldozer put some special care in those nuts. Lining these parts. Changing the pivot, there we go. And mirroring it to the other side, since there's actually two of these parts. And aligning it slightly with the blueprint. After removing Turbo Smooth, I can attach them. Now it's time to create these small rollers on the inside. And these rollers, they'll be really easy models. So they're just cylinders with a few insets and extrudes. I need to exactly align these rollers with the axle. And it turns out that my axle isn't nicely aligned with where I want the rollers to be. So I'm going to manually move the axle and surroundings, which isn't an ideal way, with the position of the roller. Once that's done, I can start modeling the roller. Forming a few bevels, moving this inwards. Once that's done, a few connects. With these connects, I can then do an inward extrude. Do a few, then an inset. Once that's done, I'm going to perform another inset here for more control edges, and an inset at the back. Even though you won't see it, I want those edges to be controlled. That roller is looking okay. Since I changed the bracket at the right side, I want it to mirror to the left side. Then I'm copying the roller over there as well. And once again, I need to take care of aligning my pivots correctly just so it looks correct. There we go. Pivots align. That should be good. Then I'm attaching this. And right now I'm linking the rollers to the main assembly so that I can easily select them all at once and duplicate them. Interestingly, some of them are mirrored and some of them are not. And some that are mirrored have a few parts that aren't mirrored. So I have to turn them into a copy, then unmirror that copy, and get it back into the correct position. Annoyingly, the top of this part needs to be extruded more because you could see the open end. Something like that, slightly rotated. Just modeling that so it looks correct. Once that's done, creating the next copy. And this one will be an instance. Slightly adjusting this instance. Then I'm creating another copy of this bracket to use at the very far end of the main suspension part. Just scaling it up slightly, making it a little bit beefier, as is visible on the ref. Once that's done, moving the axle slightly to get into a correct position. Move all of these into a correct alignment. This is looking like it's almost there. Also, the axle sits more towards the top, so I'm moving that. It's also a lot smaller. So right now I'm just very carefully scaling this and moving points into position, making sure not to select the wrong ones. And that looks about good. Something went wrong at the back here, which is not really a big disaster since I can just simply delete all of that. With the main part of the suspension hidden, I can do a few adjustments which when possible with those parts visible. And I need to extrude these parts, and since you can use an extrude on edges there, I'm just capping it and doing a quick extrude of a polygon there, which is much easier. The reason for that is I want to connect these parts, since I'm pretty sure that on the real bulldozer they are connected, since they seem to swivel over a common axle. I'm just going to connect them up. I'm going to use the cut tool to add some of this necessary geometry. Once that's done, an extra extrude here. Obviously, this part's going to need some fixing, so I'm target welding these things together. The inside of this mesh isn't perfect, but it will not be visible at all, so I don't need to put too much care in that. I'm hiding everything, and this looks like it's a little bit too soft, so obviously we'll need to add another control edge there. Once that's done, I'm copying that part to the front, and it's almost the same system at the front. The only difference is that this beefy part at the front is rotated at a different angle. I'm just rotating this. And moving it into the correct position. I need to unmirror that part, so I'm just simply detaching it, doing a mirror, and then moving it back into position. Once that's done, I can just simply reattach it. With that fixed, I go back to the part at the front. There's some small problems here from moving some verts that shouldn't be moved, just moving them back into position. Once that's done, I'm bridging the inside. And there's a little problem with bridge here. I need to add a twist there that fixes things up. I'm attaching these parts together because that will make it easier to work with later on. As you can see, only one of them has been attached together. So what I'm going to do now is work on this a little bit further and then copy it to all the other parts. I'll select these elements, all of them, just delete them, then go back to this mesh, select all the elements that I just worked on, detach them as a clone, of course, then into object mode, and then simply duplicate them to one of these. Once they're aligned, they should be in the correct position. And I can attach them. Since it's an instance, I don't really need to copy two. I need to repeat the same deal here. Take this element, and copy it over. You need to remember to mirror it since it slightly changes the proportions. Then I attach it, and we've done most of the suspension by now. Just a few things that need to be fixed. I need to add a plane on the inside of the open ends at the front, just that I don't have a gaping hole there, which would be a problem. Once that part is mirrored, I attach it and then do a real simple adjustment of these edges so that they sit in the correct position. For the final step of the suspension, I'm selecting all the rollers, aligning their pivots with the correct Y position, and then I'll just simply perform a mirror on them. And that's it for the suspension.